Yes, Miss Barbara. Good day to
Okay.
you.
Yes, I understand you'll only be on for an hour, right?
Yes, Miss Barbara.
Okay. Well, okay. So what we'll be doing today, we'll be doing actually three things. One is we'll be finishing up the probability statistics worksheet we were on. We only had three problems, I think. Uh, 18, 19, and 20. And before that, I wanted, hello, Maureen.
Okay, I got it, please.
Okay, I was just saying what we
Thanks,
will
Chief.
be doing today. We will be finishing up our last worksheet on probability and statistics, problems
Yeah.
18, 19, and 20. And before we do that, I wanted to go into what an independent event is and what a dependent event is. You may already know that, but just in case, I want to review it, all right? And then you'll have a practice sheet, and I'll show you on the screen, but I'll email it to you, and that I want you to do and send me the answers for before the next session, before the next Monday. Okay.
Okay.
All right. So let's just first look at, let's go to share screen and the whiteboard. Now, give me an example of a dependent event. This is dependent event. Now, what does dependent means? Whatever happens will affect what happens after. Okay, we calling that a dependent event.
Whatever happened.
Yeah, like in
Can you repeat that?
probability, an event that happens is affected by the event that may have happened before it. Okay, it depends on what happened before it. So we call that a dependent event. I'll give you an example. Okay, dependent event. Now, a card deck has how many cards?
52.
52, right? So we have 52 cards in a deck, right? That's total of 52. We have hearts, clubs, diamonds, and spades, right? And each of those are what? 14 cards. They're 14 cards, right? Well, 4 in the 52. I'm sorry, 18. Is it 18?
No.
13. Oh,
13.
I said before 13. So
13.
that's 13 cards per suit, right? Okay, 13 cards, and we call that a suit. And we have 2 black, and the black are spades and clubs, and the red is what? Diamonds and hearts. Now, so you have 15 cards. If you remove one card, right? Let's say we remove one card. How many cards do you have left?
51.
You have 51, right? So if you take one card out, you have 51 cards left. You don't use that 52 as possible for your next probability. You would use the 51, right? So that's a dependent event. When you take a card, or if you took out a heart, you now have 12 hearts left. So that's what we mean by a dependent event. One where the event that occurred before affects the one that occurs after. So keep that in mind for a dependent event, that when you're doing probability, you may be using the possible initially, but if you change something, then that possible becomes different.
Yes.
You follow? And that's a common mistake that people make with dependent events. They try to use the possible even though things have changed. So if you took two cards out, you'll have 50 left. Now your possible will be 50.
Yeah.
Got it? That's what we mean by dependent event. Now, when you go to an independent event, give me an example, Maureen, of an independent event. Something
Independent.
that's not depending on what you did before. Maureen, you know one?
No.
We've been looking at them. What about a coin? A coin has two choices, right?
Yeah, head and tails.
Head and tails. The fact that you pick a head the first try doesn't mean you can't pick a head the second try. It's independent. It's still 1 out of 2, right? It's still possible 1 out of 2 total. That doesn't change. So if you pick one coin, it's 1 out of 2. If you pick another one, 1 out of 2. So if you're doing 2 picks, the probability is going to be the product of those 2, which is 1/2 times 1/2, which is 1/4. You got it? So you know a coin, tossing a coin is an independent event. The second coin doesn't know what you tossed on the first try. It doesn't really care. But it's still 1 out of 2 because you only have 2 possible, head and tail.
Yes.
Another example, one we've been looking at. What about the die, the dice?
Up there. Yes.
So a die has how many sides?
6.
6 sides, right? And each side represents what?
Number.
Each side represents a number, okay? So you have 6 sides. You could pick a 1, you could pick a 2, a 3, a 4, a 5, a 6. So it's always 1 out of 6 that you'll pick a 2 or a 3 or a 4 or 5 or 6. So those are independent events, okay? You're not affected by what you picked before. Your probability is still 1 out of 6. It's 1 out of 6 that you'll pick a 6 or 1 or a 2 or a 3 or 4 or 5, because that's what the sides represent. 6 numbers, 1 through 6. Now, suppose I ask you, what's the probability for on a die of picking a prime number? You know what a prime number is, right?
Yeah.
What's the probability of picking a prime number if you roll the die?
The prime number is like 3, right?
From 1 through 6, Vanessa, what are the prime numbers?
1, 3,
1
5.
is not a prime number.
3 and 5.
What are they, Vanessa?
3 and 5.
What about 2? Isn't 2
5.
prime? You can only multiply 2 by 1, right? You can't multiply it by anything else.
Okay.
So it's 2, 3,
3,
and 5.
5.
That's right. 2, 3, and 5. Because 4 and 6 are composite numbers. Because 4 can be multiplied 2 by 2. 6 can be multiplied 3 by 2, right? So if you roll a die, what's your probability of picking a prime number? Possible is what?
How do you do it?
A
3
5
over
over 6.
No.
Is it
How
3
many?
over 6?
That's it, Vanessa. 3 over 6. Because you have 3 possibilities. We just put them here. 2, 3, and 5. So your probability, right, Maureen? Probability,
Yeah.
possible.
Yeah.
There are 3 prime numbers, right? And there are a total of 6 possible on the 6-sided dice. So 3 over 6, which is 1 over 2.
Yeah.
And you can also express it as what? 50%. Remember, probabilities can be expressed as fractions, decimals, okay, 50%. Or you could say what? 0.5. All this is a way of saying the probability of getting a prime number when you roll the die is 3/6 or 50% chance of getting it because there are actually 3 out of the possible 6 numbers on the die. Okay. Any questions now on dependent or independent events?
Mm-mm.
Okay, so let's go back now to our, we want to go to our, let's see what we were doing. 18, I think we did one of these. Okay, Vanessa, did you do number 18?
No, Miss Barbara. No, Miss Barbara.
Okay, Maureen, did you do number 18?
I do number 18, but I don't know if I did it right.
So what's your answer?
I get C.
You got C? Okay, tell me how you got C. Okay, probability equals what? P equals, we'll put possible
P.
divided by total. Total
Mhm.
possible. Okay, that's equal. So what's the probability? So what's the total number of marbles, Maureen?
There is 10 marbles. 7, 2 is
In the
9.
bag, how many are there?
10.
They're 10, because 7 plus 2 plus 1 is 10, right?
Yeah.
Now, how many blue are there?
7 blue.
7. So possible would be 7, right?
Mm-hmm.
Impossible 7.
Yes.
And what's the total?
10.
10.
10.
So that's 7 over 10.
10.
And what is that equal to?
Or 70.
Yes, 0.7,
Yes.
right? 0.7.
Two,
Okay.
7.
The other way around. Okay.
2.
There's an error there. What is that? Maureen, why didn't you stay with what you had?
Huh?
Why didn't you
What?
stay with what you had?
Because
0.7 is the probability of getting a blue. We're supposed to find the probability of not. So there are 2 ways you can do it. You could say 1 minus 0.70 equal 0.30. So your answer is what you said, Maureen. What happened? You didn't stay with your answer. Maureen?
my answer was right.
Yes, but why didn't you stay with it?
Oh,
I want to make sure you know why you said what you said. Because the answer, I mean, the question was, what is the probability of not drawing a blue? Okay. And there are 2 ways you could do it. You could find the probability of drawing a blue and subtract it from 1, or you could take the ones that are not blue and divide by 10, which are the green and the red. So you could say probability, there's different ways you can do it, equal possible 3 over 10, and that's equal to 0.30. Remember, your total probability can be the number 1. It could be 100%. Okay.
Okay.
1 is the 100%. So 2 ways you could do it. Probability of getting a blue is the blue total over the total of all the marbles, 7 over 10. The probability of not getting a blue would be 1 and subtract the 0.7 from it, you get 0.30. Or you could have said, okay, I have 7 blue, 2 green, 1 red. I have 2 green, 1 red. So I have 3 marbles that are not blue. 3 divided by 10 is 0.30. Got it, Vanessa?
Yes, Miss Barbara.
Okay. What's the probability, Vanessa, of not getting a red?
Not getting a.
Probability of not getting a red. That's what I'm asking you now.
Okay. Probability of not getting
Probability, I'll write it down. Probability of not
getting
getting a red marble. Now that you should be able to tell me right away, right?
Okay.
What is it?
28.
The probability of
4.
not getting a red.
20. Mm.
Well, let me ask you, what's
Do
the
you-
probability of getting a red?
Getting a red or not getting.
What's the probability of getting a red? We'll do it that way because you can do it like we did the 2 ways up here. What's the probability that you get a red? What's the possible red, Vanessa?
Yeah.
How many red marbles are there?
1.
So your possible is 1, right?
Yes.
And what's your total?
10.
10, that's right. That's all your marbles. So the probability of getting a red would be 0.10. Now, remember I said you can subtract that from 1 and that gives you the probability of not getting a red. So that's probability, let me write it here,
Yes.
of getting a red marble. Okay, now what's the probability of not getting a red, Vanessa? How would you find that?
Oh, so therefore, so you add 7 and 2 is 9. 9 over 10.
That's right. You could say 9 over 10.
Okay.
Or
so it could be 0.90.
That's right. Or you could say 1 minus 0.1.
Okay.
Because both of those give you 9/10. So you get 9/10.
Yes.
Wait, 0.9 or 90%, right?
90%.
So the probability of not getting a red is 90% because you have 2 other colors that add up to 9.
Yes.
7 blue and 2 green add up to 9.
9. Yes.
Okay.
Yeah. Yes.
Maureen, what's the probability of getting a green marble?
A green would be like 2 over 10.
2 over 10. That's right, because they're possible 2 greens and they're a total of 10. Okay. Now, let's take this a step further. Because we were talking independent and dependent events. Okay. Suppose you remove a green marble. Okay. Now, tell me the probability of getting another green.
If you remove 1.
Yeah. 7.
Another
plus
green marble.
1.
So we took a green marble out. We didn't put it back. We took it out. And I want the probability of getting another green marble. What would that be, Vanessa? Tell me the formula. What would it be? What's the possible?
The possibility of getting another green marble
is 0.
What's the possible green if I take 1 out, Vanessa?
Oh, if you take 1 out, therefore you would only have 9 remain.
How many green would I have?
You would only have 1.
You'd have 1, right? And then what's my
Yeah.
total? You said it.
1 over 9.
That's it. Very good. Very good. 1 over 9. Because I took out a green. So now my greens are down by 1. And my total is down by 1. So you don't put the 10 in again.
Yes.
Because if you took out a green, I had 7 blue, 2 green, 1 red. If I remove a green, I have 7 blue, 1 green, 1 red, for a total of 9. So the probability of getting another green, if I take a green out, will be 1/9.
9.
Now, I took a green out, right? Now, what's my probability of getting a blue marble?
Your probability of getting a blue marble.
Okay,
Well,
probability.
Getting a blue marble.
I remember I removed the green, right? Probability of getting
a
blue marble.
Well, that'd be 7 out to 8.
So the probability, what would it be? No. Remember I said I'm still removing a green.
Yeah,
And now I want to know the probability of getting a blue marble after I remove a green. What is it, Vanessa?
1 moment. Let me just show.
How many green marbles are there?
1 remaining.
Well, I'm sorry. How many blue marbles are there?
7.
Okay. I only took out the green, so I still have 7 blue marbles left, right?
Yes.
So my possible would be what, Vanessa?
7/9.
So that would be 7/9. That's right. Because I only took 1 out now, and that was a green. So that left me with 9 marbles, but I have 7 blue. So my possible is 7 because I didn't take out any blue, right?
Yeah.
So the probability of getting the blue is possible 7 divided by the total 9. Questions?
Bobby, give me a few minutes, please.
Yeah, okay. Maureen, questions?
No.
Okay. All right, Maureen. Suppose I remove, let's go a step further. Okay, and we're going up to the next screen. Okay. Now I remove 1 blue marble and 1 red marble. Okay. Now, my question is, what is the probability of getting another red marble?
So that'd be like 1 out to 8.
You remove a blue and 1 red.
Okay, I took a red marble out and a blue, right? Now I want to know what is the probability? What is the probability of getting another red marble? What's the
probability of getting another red marble, and you remove 1 red? There's only 1 red, Miss Barbara.
So what's the probability?
0.
You're right, because the possible is 0, right? Is 0. And if I took 2 marbles out, that's over what? 8.
Let's over 8.
That's total is not 8. So the probability of getting another red would be 0 because I only had 1 red. So in my numerator, I have possible, which is 0, divided by the total, because I had a total of 10, but I took 2 out. And so that's 8 left. So the probability would be equal to 0. So that means you have no chance of getting another red because you removed the only red you had.
Yes.
Got it?
Yeah.
Okay, so now you understand now how it works when you're working with probabilities that are dependent. These are dependent probabilities. What you get is dependent on the event that occurred before it. And in this case, the event occurred before it is you took out a red. Well, actually, you took out a blue and a red. And that means you took 2 marbles out. So 10 marbles now become 8. So your total is 8. And since you only started with 1 red, you had 0 red left. So your probability is 0. Okay, so now you understand how the dependent events work, right? Remember, you always have to look at your total because your total is changing because you're changing the amount of data that you have. Okay.
Yes, that's true.
All right. Now, in the case of a spinner, you know what a spinner is?
What?
Anybody know what a spinner is?
Spinning means something, something like it's like a thimble.
Like what?
Nobody say something.
Well, what? Describe a spinner.
A spinner is something that got a little point at the bottom when you spin it. I don't know.
No, it's usually, what
It's
is
like
it?
the toys that you see those kids with and they just spin it around. Is that what you're
Okay.
Well, no, I'm talking about, no, that's not the spinner I'm talking about. Have you seen the spinners? Well, I think one of the closest things to it real world is probably a roulette wheel where you have numbers around it. Well, a spinner is just a, well, let me just, let's go to the whiteboard. Okay, and we'll clear this. Yeah, a spinner is, and let's just draw a circle here. Okay. Yeah, it's like a circle, and you have numbers around it, like 1, 2, 3, 4, 5, 6, 7, 8, right? And you spin it and you get on a number. It could be a 2, it could be a 3, a 4. Now, when okay, so there are numbers on this spinner. Let's see if I can put a text box here. Okay. Now, let me just put, see it, bring this in. Okay. Now, let me just put a 1 here. All right. And then I'll put another text box here. Okay. And I'll put a 2 here. All right. Okay. Now I'll put another text box. I just want you to see the numbers. Okay. And let me move this over and put a 3 here. Okay. So when you spin it, you could get, well, I could put more numbers. It's like 1, 2, 3, 4, 5, 6, 7. Just say I have 10, right? Now, when I spin this, I could get on either number, right? Would those be independent events or dependent events? When I spin this, because you have a device here in the middle and you can spin it and you fall on, you have a, let's see if I can.
Be something like a compass light, spin it.
Let's see if I can. Okay. And let's say I get here on a 2 when I spin it, right? Now, if I spin it again, can I get a 2 again? Yes, no?
No.
Why not?
Depends on how you spin. If you spin slow, you can't get the next 2. It's impossible.
What do you mean impossible, Maureen?
Okay, if you get a 2 and you spin it again, it's impossible to get a 2.
Well, okay, let's establish now we're spinning at the same rate each time. We're not changing the rate. Okay, so we're spinning at the same rate each time. Can I get a 2 again? Yes, no? What do you say?
No,
Vanessa? Why
you
not?
can't get, because there's only 1, 2.
There's 1, 2, but remember I'm spinning it. I
You
don't know
can
where
get-
I don't know where the point is gonna end.
Right. Depends. Yeah, you can spin it.
So you could get 2, 1.
and
So you could
go back down
get
to
2, 2. You could get 2,
Yeah.
1 and 2, 3.
Well, you can only land on one number
Yes, yes.
for the
yes.
spin. My question was, if I spin this spinner and get a 2, Is it possible on my second spin, I'll get another 2?
Let me see,
No.
because there are 3 numbers.
Well, there's more than
3
3.
over.
Actually, I only put 3 here.
Okay, just put 3.
I only put 3 here.
I got
Actually,
the extra
actually,
from the foot with
they're,
the back
they're,
too.
they're 10 numbers, right?
Yeah.
Okay.
Let me go here and put a 4. Okay, I just didn't put them all. See, they're actually
Yeah,
10
but you
numbers.
can't get enough. It's not a possibility
Why not,
that you
Vanessa?
can get, because there's only 1, 2, or there's only 2 is only there once.
But remember, I'm spinning this. This is a mechanism. Right in the middle here, I have something that I'm using to spin this, right?
Yes.
It's in the middle.
Mhm.
So I spin it, I get a 2. My question, if I spin it again, can I get another 2? You said no. Why not?
No. I said
Why?
no. Because okay, let's use, because it's 4 numbers we have, and you do 2 over 4.
Well, actually, it's not 4. It's this goes
10.
all the way around. It's
It's
10.
Okay, 10 numbers.
It's just that I didn't put them all here.
Okay,
So
it's
it's
10
1, 2,
numbers.
3, 4, 5, 6, 7, 8, 9, 10. So there are 10 numbers on this spinner. So the spinner has, let me just
Okay,
spinner
that's 10, 2, right?
has 10 numbers. Okay. 1, 2, 10. So the spinner has 10 numbers. And each time I'm spinning, I have a mechanism here in the middle, and I'm spinning at the same speed. My question was, if I land here on the 2, if I spin the second time, can I get a 2 again? And you said no. Why
Oh.
not?
Because there's only 1, 2.
It's only 1, 2, but remember, this is a random event here, right? So I could spin again and get a 2, or I could get a 10, or I could get an 8.
Yes, you can
It's
get
not
all
the
the
fact that
numbers.
it's what it's, that's it. It's not the fact. In other words, it's not the fact that I got a 2 that I can't get another 2.
Okay. Yes, that's true. It's not a fact. That's
Correct?
true. Yes.
So that
Yes.
means I could spin and get a 2. I could spin and get a 5. I could spin and get a 1. I could spin and get a 1, and I could spin and get a 1 again.
Yes.
Mhm.
Right? So is that independent or dependent?
That's
That's independent.
That's right,
yes, that's
independent. The
independent.
getting a 2 does not affect that I don't get a 2 again.
Yeah, okay.
That's an independent event, right? It's not like, well, you said, no, there's only 1, 2, but that's not the same as like head and tails. There's a head and there's a tail, and I have a 1 out of 2 chances of getting a head, a tail.
Yes,
But
yes.
on a spinner, I have 10 different numbers, and when I spin, there's a possibility that I could get any of these numbers, and I could get them back to back.
Okay.
Okay?
Yes.
The fact that I get one number is independent of whether I get that number again or a different number.
Okay.
That's what a spinner, that's what we call a spinner. Okay?
Mhm.
So I could get a 5, I could spin again, get a 6, I could spin again and get another 6.
Yes.
Okay? The spinner doesn't know that you landed on a number before and you can't land on it again. It doesn't work like that. It's a random operation, okay, of spinning. Okay?
Yes.
All right, let's go back to our sheet that we was working on.
Mhm.
That was number what? 18. Okay, now let's go to number 19. And that says, what is the problem? I think we did that one. Maureen, you remember? What's the probability of not getting a 3 on a dice?
I put 5 out of 6 a D.
6. 5 over
Yes,
6.
5 over 6, right? Because
Yeah.
there's 6 numbers. Okay, so that one you know. Answer D, because there are 6 numbers
Mhm.
and there are 5 numbers that are not the 3. So the
Yes.
probability is 5/6.
Mhm.
Okay, what's the probability of not getting a 1?
1/6.
No, not
No.
getting a 1.
5/6.
That's right. We 5/6,
That's it.
right? And what's the
Yes.
probability of getting a 1?
1/6.
1/6, because
1/6.
possible
Because there's
there's only
only one.
1. That's
One,
right,
yes.
Vanessa. There's only 1, so it's 1/6.
6.
Okay.
Yes.
What's the probability of getting a 1 and a 2?
2 over
Okay, I'm asking you this. This is on the die. What is the probability of getting a 1 or a 2?
What is the probability of getting a 1 or 2?
Okay, when you roll the die, what's the probability of getting a 1 or a 2? What's the probability of getting a 1?
1/6.
1/6.
What's the probability of getting a 2?
2/6.
No,
No.
it's still possible. There's only 1 2 and there's only
Yes.
1 1. So the probability of getting a 1, you told me, okay, probability
1/3.
2/3.
getting a 1, and you said that's equal to 1/6. Okay, probability
Over 2.
Over 2.
of getting a 2, and that's equal 1/6. So what's the probability of getting a 1 or a 2?
Okay, a 1, you would have 1/6. A 2, would you have 1/3? Would it be that?
No, of getting a
Over
1
two,
or a
over
2?
2/3.
No, with a 1.
Over 2 1/3.
You said not getting?
No,
Okay.
getting. What's the probability of getting a 1 or a 2?
Oh, getting a 1 or a 2.
Yes.
6/6.
6/6?
No, it can't be that. No, this is not.
Over 2/3.
No.
Nope.
So a third.
No. Remember what I said when you have 2 things here, probability when you multiply. So probability will be 1/6 times 1/6.
So it would be, so if you multiply that.
No, I don't think that's right. I think it's 1/6 plus 1/6. Not the multiplication. 1/6 plus 1/6. I think
So-
somebody told me the answer. 2/6.
2/6.
Either 1/3.
1 and 3.
Yeah,
Yes.
1/3. You're right. Somebody told me that answer. Yes.
Yeah, 2/3.
Yeah, you
Could
add
as
up the
well look at.
probabilities of the 1/6 plus 1/6.
2/6. Yes.
So there's a 1/3 chance of getting a
Chance.
1 or a 2.
Or 2. Yeah.
Okay. Questions?
No.
I think we had one more. 20.
We had 20. We had 23. Oh, you had 70.
Oh, that's right. There was more than that, right? 20. Okay, what about 20? What's the probability you pick a white or a blue?
Let me see, a box is filled with cubes of different colors. There are 40, right?
Yes.
There are 40, total of 40.
Together them is 120, right?
Right? Different colors. There are 40 white.
Yeah, this is another one where you're gonna add the probabilities.
Fill
So
it
Yeah,
down.
let's
so 20.
okay.
No,
So what's the probability of getting a white? So we'll just take the first one. Okay, probability of getting a white.
it says 140 is the total.
Is it no 40, 64,
It's 120.
76? It's 120 total, Vanessa.
120.
Probability of getting a white. So let's say probability of getting a white, Vanessa. What would I put here? How many white are there?
40 over 120.
That's right. 40 over 120. And let's simplify that. That's equal to what?
Yes.
40 over 120.
40 over 120. Okay, it would be 1/3.
1/3.
Because
Okay.
if you remove the 2 zeros,
That's right. It's
24
412.
is,
Okay.
yes.
Now
Mhm.
let's go to probability of getting, okay, a blue. What would that be equal to, Maureen?
The probability of getting the blue.
Yeah, how many blues are there?
Blues.
How many blue cubes?
20
20. So that's 20 over what?
120.
or 120.
120. And that's equal to what, Maureen? Simplified.
40 over 120.
2 over 12.
Could be 0.6.
What's 2 over 12, Maureen? Simplified.
2 over 12 is a half, 1/6.
Well, a half is not 1/6.
20 over 12 over 6, right? It's a
Yeah,
half.
well, it's not a half. Half of 12 is 6.
Yeah.
Mhm.
So 20 over 120 is 2 over 12, and 2 over 12 is 1/6.
1/6 or
Okay.
0.60.
Yeah, but what's the probability it says of white or blue? That means you've got to add, right? So probability would be the sum of these two equal 1/3 plus 1/6. And what's that equal to? 1/3 is how many 6? 2 6, right?
Yeah.
Plus 1/6. And that's equal to 3 6. What is that equal to simplified, Maureen? 3 over 6.
Just 5.
1/2.
1/2. Very good.
Mhm.
Okay. So what's our answer?
D.
I
That's
got
right.
these.
Answer is D.
Well,
D is 1/2. Okay.
Mhm.
So white or blue, you find the probability of getting a white. It's similar to the one we just did before. And you find the probability of getting a blue and sum those probabilities up. And that gives you the probability to get a white or a blue. Questions on 20?
No.
We need to get more of these. These are good.
Yes, yes, you're right. Yeah. What's the probability of getting a green?
Well, a green, how many greens here? So therefore it's 24 over 120.
And that's equal to what?
24.
24 would divide into 120, what, 5 times?
Okay, yes, 1/5
So
or
it's
0.50.
1/5. That's right.
Or
1/5.
0.50.
That's right. Or 50%.
Yes.
Okay. What's the probability of getting a green or a red? All right.
Green or a red.
What
So do I have to add the 2?
Get the probabilities and add them. What is the probability
Of getting a green?
So that'd be like,
green or a red.
that'd be
12.
2.
of
Place
getting
32 over 120, right?
A green or a red. All right.
4 over 15 or
What would it be?
4 over 15 or
So for the
0.26?
green, what would it be for the green?
Oh, you
20,
want me to do it
what,
different?
24 over 120, right?
Let me do it
That's
separate.
the green.
The green is 24.
You could add them together and divide by 120. You get the same thing. You could add the 24 plus the 12. All right, so you could do that,
That's
or you
36.
could do them separate, or you could add them. In other words, Vanessa, you could say green and red is 24 plus 12 is 36, and 36 over 120.
36.
Give you the same answer. So
Yeah,
red
36.
is 12 over
3 over 10.
120. That's the red.
So if you add them together, therefore you
What do you get?
3 over 10, which would give
You
you,
could say 36
yes.
over 120. What's that equal to?
Yeah, 36 over 120.
Yeah, you could add them together.
So therefore you get
What's that equal to?
0.3.
0.3.
Yes. Yes, Ms. Barbara.
So what you divide it by 12, right?
I
12 and
divided.
36.
No, I add 24 and 36. 24 and 12 and divided by 120.
Yeah. Or you could divide what? By
Do it
12.
individually. Okay.
Well, 12 and the 36 is 3 times, and 12
Yeah.
and the 120 is 10 times.
10 times.
That's your least stubborn.
So that would be,
Denominator is 12. 12 and the 36, 3. And that would be, well, you said that you could put it as decimal. 0.
fraction,
Yeah, or you could put it as
which is
decimal.
30%.
Yes, 3 or 30%. That's
Percent.
right.
Mhm.
30%. Right. So the probability of getting a green or a red would be 30%. You could do them separate, but then you could add them up. 24 and 12 is 36, and divide by the total. Possible red, green or red is the sum of the reds plus the greens, and then the total is 120. So that would be 30%. The 30% probability of getting a green or a red. What's the probability of not getting a golden?
Not getting what?
A golden. Remember, it's white, green, red, golden, and blue. So what is the probability of not getting a golden cube?
So therefore, if you're not getting a golden cube, therefore you cannot count golden.
So what would be your answer, Vanessa?
So if you do not count the golden, so 40 plus 24 plus what, 12
So 40, let's
plus
put here,
20,
40 plus
right?
24
40
plus 12
plus 24
plus 20. All right.
40
That's okay.
plus
So we're gonna add that. Put that in
24
parentheses,
12
and we're gonna divide that by what, Vanessa? The
plus
total.
20. So the 20 is 96.
So what do you
Right?
get? What do you get for
One-
your answer?
Moment, 96. And you divide it by,
Four,
you divide it
okay,
by
96. Okay, that's correct.
Mhm.
And that's divided by the 120. And what is that equal to?
1 moment. 90, 1 moment.
What's
Okay,
your least
96
common
by
multiple?
1. So it's 4/5, which is 0.8, or in percentage, we get 80%.
You get 4/5.
Yes, as a
What was your,
fraction,
okay, what was your least common denominator here for 96 and 120?
120. To do the least,
Or you could just
96
divide it
divided
out.
by 120.
write it
0.
out.
Or you could just divide it out, right?
That's what I
96
did.
divided by 120. What did you get? Your answer?
Oh, me, Ms. Barbara?
Yes, yes.
Okay, either 4/5 as a fraction or in
Okay.
decimal, 0.8,
Right.
or as a, we call it,
Percent.
as a percent, 0.80.
No, percent would just be 80%.
80%, yes, 80%.
So there's an 80% chance of not getting a golden cube.
Yes.
That would be the ones that are not golden, which are the white, the green, the red, and the blue. Okay. All right, good.
We got a 21 now.
Let's see, you have 21. Let's see, I have to go to 21. Hold on a minute. I think I've got to get out of here. Go to 21. Give me a minute or so to get to. I don't think I had 21 on here. I sent you 21, but I don't think I have it on.
Yeah.
Let's see. Let's see if I have it.
Barbara
Yes.
and Ms. Beckles, I'm leaving.
Okay, Vanessa, I will send you the worksheet to do, and you can send me the answers by next.
Sure, and can you send this to me also?
Yeah, I'll send this. Yeah, I'll save this. The practice sheet has 10 questions. I'll send that for you to do and send back me the answers before next Monday. Okay.
Sure, Ms. Barbara.
Okay.
Thank you
All
so
right.
much.
All right,
Okay,
Maureen. Well, I'm looking
Take
for
care.
the 22. Let's see, the 22, 23. No, it's not that one. Okay. 21, 22, 23. Okay. All right. Let me. Sorry, Maureen. I'm trying to get back.
No problem.
Trying to get back in. Okay. No, that's not the one. Okay. Can you see that? 21, 22, 23? Maureen?
Yeah.
Okay. Let me go back. So you can see 21, 22, 23, correct?
Yeah.
All right. Did you, okay, 21. Certain game, players toss a coin and roll a die.
Mhm.
The player wins if the coin comes up head or the die with a number greater than 4. Now these are what? Independent or dependent? Maureen?
Independent.
Independent, that's right. So for a coin, you have two choices, head or tail. For a die, you have numbers 1 through 6, okay? So what's the probability of getting heads on the coin? Maureen, what's the probability
Probability of getting a coin.
of getting head?
Like one? I could only get one coin. Hey,
What's the probability of getting heads?
I mean, getting head is. I don't know. I can even figure out this thing, you know.
Well, probability, you only have one head, right? So that's
Yeah.
1. And you have 1 out of 2 chances, because possible is heads. The total is heads, tail. That's 2. So the probability of getting a head or a tail is 1/2, correct?
Uh-huh.
Okay. Now, what's the probability of getting? Okay, that's the coin. Now,
Uh-huh.
on a die, you have number greater than 4, right?
Yeah.
So die, you have 1, 2, 3, 4,
4,
5,
5,
6.
6,
So how many numbers are greater than 4?
2.
2. All right. So you have 2 out of 6. This is for the dice. Probability. So that's dice probability of getting number greater than 4. All right. That would be probability equals, and number greater than 4 is just 2, right? So 2.
Yeah.
So that would be 2/6 equal 1/3. So the probability on the dice of getting a number greater than 4 is 2/6, or 1/3. Now, it says in 20 games, how many times will a player win? So the probability of getting heads or greater than 4 would be 1/3 times 1/2. 1/3 times 1/2, because it's the probability with the coin times the probability of the die. Okay. All right. Hold on 1 minute. Let's see. Get. Somehow I didn't have those on my. Did have those. Let's see, 20. Somehow I didn't have those on my sheet. I don't know why. Let's see. Sorry, Maureen, I'm trying to find
No
it.
problem.
Let's see. I think we may have to come back to that one, Maureen.
Okay.
Somehow I lost it on my screen. Okay. Now, so do you see 21, 22, 23?
Yeah.
Okay. All right. Let's go to 22 because
Okay.
21 I have to come back to.
Okay.
22, okay. Two balls out of the bag. And so what's the problem to have a blue and a white? Okay. Maureen, did you get an answer on the 22?
On the 22,
You have how many
no.
blues and how many whites?
So what is the probability of to have one blue and one white? So that is one and one is two.
So,
Okay.
okay. So if
There's
you
three,
take,
four,
okay, you're taking two balls out of the bag
three.
consecutively. Okay, so let's just take the blue. Okay.
So there's three blues, one white, and four reds.
Okay, so if you take
So
two
that is
balls out of the bag consecutively,
that
what the probability of getting a blue and a white? So for the blue, it would be what? Probability equal, let's see. Let's see, there are three blues, three, four, 8. Okay.
one white and four reds.
Okay, so if you take, so if you take a blue out, you'd have what? Two
You got
blues left. And let's see, 3, 4, 8. Let's see, that would be 2/7.
so that'd
If,
be if you take out three,
okay, and if you took the
blues,
white, let's see, if you took the white, you have probability equals, let's see, that would be, okay, so that would really be no whites. Okay, so if you took a white
there's
out,
three, four, there's step balls and all, right?
yes,
Right.
so
Yeah.
3, 4, 8.
So if you take out one blue,
Yeah, if you take out a blue, okay, so that's removing a blue ball. Okay. And then if you remove a white, actually we
That
remove,
be
okay. But then you'd have no whites left. So if you took a white, actually it would be 0/6. Let's see, we use three blue, one white, four red. Take two balls out of the bag, a second would probably have a blue and a white. So with the blue, you have two left. If you took out a blue, with the white, you'd have none left.
mhm.
And that would be 0/6. And I don't see the answer there. That would be 2/7 plus 0. And neither answer is there.
If you take out two balls, it should be like 2/6. Because it was only 3, 4, 8 balls. Well, you got 2/7. I don't know.
Yeah, but if I took out a blue, I have 3, 1, 4, 8. That's 7 left, right? Just take out one blue. I have 7 left.
Oh, yeah,
And I'll have 2 blue balls. So if I remove a blue, I have 7 balls left, but then I'll have one blue. I mean, 2 blues, 3 minus 1. But the white, if I remove one, I have no white
No
because I only
balls.
have one white.
Mhm,
And then I'll have 6 because I took 2 balls out.
uh-huh.
But see, that's not enough. The answer 0/6, which is that's removing a white. And they say consecutively, so you're taking them out right behind each other. So removing a white ball. But 2/7 and 0 is not any of those answers.
Mhm.
Okay, 23. Let me look at 23. 4 red, 5 green, 2 yellow. That's 9, 11. One is red and one is green. So 5 over. Okay. So 5 over 5, 9 to 11. Okay. Look at 23 here. Okay. Probability equals, that's for the red. If one is red and the other is green, so that would be 3 red left. Well, let's just say 4 over, let's see, 9, 11. That would be red. Okay. P equals, and the red would be, I'm sorry, the green would be 5 over 11. Okay. That would be green. So the probability one is red and one is green would be 4/11 times 5/11. So this one would be probability equals 4/11 times 5/11. And that's equal 20/121. not 10, 20. So that would be answer C. Okay, so probably the one is red is 4/11. And let's see, we can use that one to find the other one. Okay. Probability is green is 5/11. And the product is 4/11, so the answer is C. Now, if I go up here and use that same reasoning, so if I have 3, let's see, over 3, 4, let's see, 3/8. And the white would be 1/8. See if that's 8. Okay. And 3/60. That still wouldn't give me the right answer. 3/7 times 1, 6. 6 times 7 is 42. That's still not giving me the right answer. Okay, well, 23, we have 21 and 22. I'll have to get back to you, Maureen.
Okay, no problem.
All right. So the next thing is, let's see. Okay. The next thing is what I'll be sending to you, and that's the practice sheet.
Okay,
Probability and statistics practice. Okay.
okay.
Let's see if this is it. Okay. I don't think it's that one. I think it's the other one. Hold on. Oh, probability and statistics practice. Let's see if that's the one. Okay. This is the one you'll be doing for Monday. You'll be sending me the answers. I'll email you this, Maureen. Just let me
Okay,
just go through it, make sure you understand. Do you see
okay.
this one, probability and statistics practice?
Mm-hmm.
What does, read number 1.
They ain't got nothing up there.
Oh, you don't see the new share? Okay.
They still got the 21, 22, and 23 in.
Okay, let me go to, you see it now?
Yeah.
What do you see? Read number 1.
3 golfers are competing for the longest distance. Their longest distance in yards over a period of an hour are as follows.
Now you can stop there. Now, which golfer has the highest mode? You know what mode is, right?
Yeah.
What is mode?
It's more is the one that got the most one number more than one.
That's right. The most numbers. So which one and which mode, which golfer has the highest mode?
Okay, let's see. 260, 267. The third,
And what is this mode?
you mean what is this mode?
Hmm. The third golfer mode is what?
Mode 260.
Third golfer?
Mm,
The one that appears the most? This 260 only appears one time. What's the mode of the third golfer?
281.
That's it.
Yeah.
281, but you said 260. But
No.
260 is only there once. 281 is
Okay.
there twice. So
Yeah.
you're right, the third golfer. So you understand what you have to put the answer for the
Yeah.
number 1. Now,
Mm,
okay. So Number 2. Read number 2.
Yeah, survey was taken on 30 classes at a school. Okay, to find, I don't can you see that other one?
Define the
Let,
total number of left-hand students in each class.
okay.
The table below shows the results.
Mm-hmm.
So left-hand students is in the first row, right? Right here.
Yeah. Mm-hmm.
Number of classes in the second row.
Well,
What's the probability the class has 2 left-hand students?
to that one student. Okay.
Or which number of classes has 2 left-hand students?
Okay, in box 3. Got the two.
Yeah, it's the 2 left-hand students here, and you
Uh,
have the classes here, right?
uh,
So the probability that the class has 2 left-hand students would be right in this column.
yeah.
And it's 5 classes here. So you have
Uh-huh.
to add up your total classes, right?
Yeah.
And that's how you would solve that.
Mm.
Okay, now let's go to number. So you need your total number of classes here.
Uh-huh.
And 2 fall in here. So there are 5 classes out of your number of classes here. So
Uh-huh.
the probability the class has 2 left-hand students would be this column, but you'd have 5 number of classes, and the total will be the addition of all of these, right?
Mhm.
Okay. So you'd have 5
So that'd be
divided.
like 30.
Yeah, that's 30, but what would be the possible? It'd be 5, right?
Uh-huh.
So you'd have 5 over 30 and then simplify it. That would be one of your answers. Got it?
Yeah. Yeah, 5 over 30 is 1/6.
That's it. So you got your answers for that one. Now let's go to number 3. Number 3, I'm going to let you figure it out. You got 2 company sets of, you have sets of data for 2 companies, and you define which of these is correct. The median salaries in both companies greater than 37,000. Look at your median here, and see if one is correct. Calculate your mean. You can add up these and divide by 4. Add up
Uh-huh.
these and divide by 4 and
Okay.
see if one greater. And then the range is high minus low. For this one, it'll be 38,000 minus 30. For this one, it'll be 65,000 minus 29. See how the ranges compare. And of
Okay.
course, the mean age. Now, this is mean age. You calculate, add up these ages, divide by 4. The salary, add up the salary. So I think you could do that one.
Okay.
Okay, let's look at number. And of course, probability. You can do this one. You know how many read.
Yeah.
You know how many total. Okay. Now,
Uh-huh.
5, a pediatrician this month has 20 working days, takes 8 days holidays. What is the probability that Monday is a work day? So you got to use your work days,
Uh-huh.
all right? And 20 working days, 8 days of holidays, right? So you got
Uh-huh.
to find out actually the number of days he worked and to find the probability that the Monday is a work day.
Okay.
All right. And 6, mean. Here's the mean. 3 of the numbers are these numbers. What is the value of the 4th number? So if the mean is 71.5, then that total is going to be 4 times 71.5. So you got to get the difference between that total and this total when you add these up. You follow, Maureen?
No, explain that again. The one
Okay,
about
all right.
71.5.
Okay, 71.5. If the mean of 4 numbers is 71.5, that means the total of those numbers is 4 multiplied times 71.5.
Okay.
You follow? If the mean is this number, that means you took some number and divided by 4 and got 71.5. That number was 4 times 71.5. Got it? Now, once you know that total, you can add up these numbers, subtract from that total that you got here, and that will give you your answer. Got it?
Okay.
All right. Now, let's go to number 7. And this one, you know, what's the probability? If the probability of winning is 15%, what's the probability of not winning?
Okay.
What is it, Maureen? What's the probability of not winning?
Okay, 15% was the probability not winning.
Mm-hmm.
That'd be like 5%.
No. The total is 100%.
Uh-huh.
If your probability of winning is 15% and your total is 100%, what's the probability of not winning?
Oh,
In
okay.
other words, the probability of winning and plus the probability of not winning is 100%. So what's the probability of not winning?
10%?
No.
No. Okay.
Probability of winning plus the probability of not winning is 100%. Got it? So if you know the probability of winning is 15%.
Oh, that'd be like 85%.
That's right. That's right. Okay. Now, the next one is a Venn diagram. You know what we said about Venn diagrams, right?
Yeah.
What is the 15 here? What does that represent?
The football,
That's right, the football. What does the 20 represent?
the hockey.
What does the 5 represent?
Okay.
20 watch hockey, 15 watch football. What do the 5 right in here do?
The 5 is 5. You got to take the 5 from the 20.
No, what does this 5 represent? This intersect right here. That's the one that watch both sports. They watch hockey and they watch football. What is the 10 here? What is that?
That the people that didn't watch football and hockey.
That's right. Excellent. The people that didn't watch hockey and they didn't watch football. That's what that represents. Okay. So you want to find what's the probability that a person chosen at random watches hockey. So you're going to need your hockey total and you're going to need your total of the ones that watched all the sports. Okay. And then simplify it. Okay. Got it?
Yeah.
All right. And let's see, number 9. How do you find the median of a number, of a set of numbers? What do you have to do first, Maureen?
You got to put you got to do it from like top to bottom, this least to the least to the greatest.
Yeah, you had to put them in order, right? Either greatest to the highest.
Yeah.
Or you could put lowest to the highest. And if it's an odd set, it's one number in the middle. If it's even, you average the 2 numbers in the middle, right? So you can do that for number 9. Okay, number 10, you got 2 independent events. You got a coin toss and a cube rolled. Okay. What is the probability the number is greater than 2? That's for the die, the cube, which is a die, and the coin toss is head. Now this is where you have to find the probability for the cube and the probability for the coin and multiply them.
Okay.
All right, that would be for number 10. Okay, now let's I am going to go back. Let me just go back, Maureen, see if I can find that other. Just hold on a minute. Maureen, do you see the share we were just on?
Huh?
Do you see a share? Do you see a screen?
Yeah.
Which one do you see? I'm not sure I
I can
came.
say
Let me go to the top. What's the heading on your screen?
my task, math, probability, and statistic practice.
Oh, okay. So we're back where we were. Okay. We're gonna stop here, but actually I will send you what we went over today. I will send you
Uh-huh.
the practice sheet,
Uh-huh.
and you will send me answers before next Monday.
Okay.
There's an algebra. Actually, there's an algebra. Let me see if I can bring it up because we will start on algebra next time.
Okay.
Okay. Now let me see if I can find. I think I had a basic algebra sheet that I had for you. Let me find it, and I'll probably send you that too.
Okay.
And we'll start on algebra next time. Let me see if I can find it. I had a basic algebra sheet that I wanted to use to go over. Let's see. Task. Here it is. Do you see this?
Yeah.
Task math algebra basics. Do you see that?
No.
Okay.
Start math probability and statistic practice.
Okay. Do you see task math algebra basics now?
Yeah.
Okay. So that I will be going over. Some of it you're probably familiar with.
Uh-huh.
If I ask you what is a coefficient, what would you say?
I think a coefficient is something before the
Go ahead. You about to say it.
something like before the number. Like you could put like
Yeah, you're absolutely right. It's something that comes before the number. Like you said,
yeah,
like if you
yeah,
say 6x, the
yeah.
coefficient is 6. All right. Now, what is an exponent?
Okay. Exponent.
Just give me an example of an exponent. Just give me an example of what an exponent is.
I know, but I really can't remember.
Yeah, it's a power.
Yeah.
Yeah, like you raise something to a power, like you say, well, like here, you see ax square,
Uh-huh. Uh-huh.
that 2 is an exponent, right?
Yeah.
That means x times x. X to the second power mean x multiplied by itself. So that's
Mm-hmm.
what we call an exponent, okay? What is a variable? These are some basic terms in algebra that you should understand to do algebra problems. So what is a variable? Give me an
I really,
example. Just
I
give me
really
an
can't
example.
remember.
No, variable is just a symbol you use to represent a number like X or A or Q or S,
Mm.
right? Those are variables. 50, what does that represent? That represents a constant, a number on its own. So in an equation, you can have a variable, like here you have X, and then you have these constants 2 and 6. Now you have to understand the basic uh, arithmetic, which is addition, subtraction, multiplication, division. Those have to be clear, and then you have to understand sign number rules in order to do algebra. Okay,
Mm.
and algebra is really it's a thinking process. You don't have to memorize formulas. It's
Okay.
just the way you think to relate items together when sometimes you don't know the value of the item. That may be something you're solving for, and that's where the equation comes in, where you set variables and numbers may be equal to variables and numbers. All
Okay.
right.
Um,
The actual operation, like we say, is just addition, subtraction, multiplication, and division.
Decision.
So deciding when to do those things when you're doing your problem solving, that's one of the most important parts of algebra.
Okay.
Looking at because most of them are not just an expression or an equation, they are really word problems. So you've got to read the word problem, determine what you're looking for, and find what you need in the word problem to solve the problem. Because sometimes you have extra work in the problem that you don't need. So you have to pick out what you need to solve the problem and then solve the problem. Now, have you heard the term polynomial?
Yeah.
What do you think it means? Polynomial. You've heard the term, Maureen, and it could be
Yeah.
monomial, one term, binomial, two terms, trinomial, three terms. Okay. Here are some examples here. Polynomials, combination of constant variables, exponents. It can have these. All right.
Mhm.
Monomial, binomial, trinomials, those are just special names for polynomials. If it's one term, it's mono. If it's two terms, it's bi. If it's three terms, it's tri.
Right.
But the whole set is polynomial. Okay.
Okay. Um,
Like terms are terms, variables, and if they have exponents, they are the same. Here's an example. What does these terms have in common? They all have x, y to the second
no,
power.
that's power.
So they have like terms. That means you can combine them. You can combine the coefficients. Like if you were adding these, you'd add the 1/3, the -2, and the 6, because
Mhm.
those are coefficients of these terms. Okay. And you
Mhm.
cannot combine them unless the terms are the same. If this was a z square, then you could combine it with these. They have to be exactly alike.
Right.
And then you can combine the coefficients, like you say, the number in front of variables. Okay.
Mhm.
Now, you see how much easier it is when you use these exponents, like over here, y to the second power times z. That's y times z. Or if you say y to the fourth, that's y times itself 4 times. So
Yeah.
it's a lot easier to say y to the fourth z square than to say y times y times y times y times z times z. See, that's a compact way of identifying it. Now, in algebra, you have what we call a puzzle. Like here, what goes in this entity right here? What goes here? What number -2 is 4, Maureen?
Two,
No, what number do you subtract 2 from and get 4?
six.
6. So the missing number, this is the puzzle. What
Uh-huh.
number 2 subtracted from to give 4, and that number can only be 6.
Mhm.
6 minus 2 is 4. Now, in algebra, we don't use these little blank boxes. We use variables,
Mhm.
X or Y, but we can use any letter from A to Z. So instead of the box, we say X minus 2 is 4. Add the 2 to both sides, and that gives us X to 6. Now, the reason we do that to both sides because we have to keep the equation in balance. And what we do to the left side, we have to do to the right
Right.
side. Okay. Now, what you have to identify is the operation you have to do to find the answer. Sometimes it's addition, sometimes it's subtracting, sometimes it's multiplication, and sometimes it's division.
Okay.
In this case, it was what? Addition. We
Addition.
added 2 to both sides, and we got, like here, we got 6. Okay, so you do the opposite. That means if you're adding, you're going to subtract. If you're
Okay.
subtracting, you're going to add. If you're multiplying, you're going to be doing division. Or if you're doing division, you're going to be doing multiplication. Important thing is to keep equations in balance. You have to do what to the left side that you do to the right side.
Right side.
Now, let's look over here, basic algebra. T plus 15 is 30. What's the only value T can be, Maureen?
Also
If T plus 15 is 30, what's the only value T can be?
15.
That's it, can only be 15. T plus 15 is 30. Subtract 15 from both sides of the equation. 30 minus 15 is 15. Left side, the plus 15 minus 15 give you 0. So that, you see they're connected by addition. You do the opposite operation, which is subtraction. Let's look at this one. Find value of y when 9y is 63. What number times y gives 6? What number times 9 gives 63? Maureen, what number do you multiply by 9 and get 63?
9 sevens.
That's right, 7. So this is a division, right? So what you do is you multiply, opposite operation. This is multiplication. I'm sorry, this is multiplication. So the opposite is division. So you divide both sides by 9, and 63 over 9 is 7.
7.
Okay, so 9 times y means multiplication. 9 multiplied by y. Opposite operation, division by 9, gives you the answer 7. Okay. Now, let's look at this one. 21 equal b divided by 7. That's a division. So you're going to multiply. You can set it up. 21 over 1 is b over 7. 7 times 21 is 147. B times 1 is b. B is equal to 147. Okay. This is a division. B divided by 7. The opposite operation is the multiplication, which is exactly what you did here. So that's how you get the value of b. Now, let's look at this problem. You go in shopping, you buy 2 dozen of eggs at $10, 3 loaves of bread at $5 per loaf, and 5 bottles of drink, each $8. How much money do you need? You got to add up the amount for the eggs, the amount for the bread, and the amount for the drinks, right?
Yeah.
So the eggs are $5 a dozen. So 2 dozen are $10. The bread is $5 a loaf, right? 3 loaves are going to be $15, right? The bottle of drink is $8. So you're buying 5 bottles of drinks. So you have to do the multiplication.
So that is 40.
That's right. 2 times 5, that's for the eggs. 3 times 5, that's for the bread. 5 times 8, that's for the drinks. Add them up, and you get the total money needed, which is $65. Okay, let's take another example. Rectangle has an area of 72 square centimeters. If the width of the rectangle is twice the length, find the length and the width. Now, what's the area formula for a rectangle, Maureen?
Length versus width.
What?
Length versus length and width.
Length what? What operation?
Multiply.
Yes, that's right. Length multiplied by width. Area is length times width. Now, if width is twice the length, in words, width equal twice the length. If we let W be the width and L be the length, then this translates to W equals 2L. In other words, the width is twice the length. So if area is length times width, then we can put for width, length 2L, right?
Yeah.
Okay. The area is 72. What's length times 2 length? What is that? L times 2L.
L times 2L.
Yeah, what's
It's
L
2L.
times? No. Remember, there's an exponent here. L to the 1, L to the 1. When you multiply, same variable, you add the exponent. So L to the 1, L to the 1, 1 plus 1 is 2. So that's
2.
L squared, L to the second power, right? So
Uh-huh.
that 2 is an exponent or power. So
Mhm.
you have 2L times L is 2L to the second power. So the
Mhm.
72 square centimeters is equal to 2L to the second power. Now, we're looking for L, right? And that's a multiplication. Opposite of multiplication is division.
And
So we divide both sides by 2. That gives us L squared on the right side. 72
1
divided by 2 is
is
36.
36.
That's it. Now, to find L, if you have a square, remember we say take the square root of a square that gives you the variable or a number, if it were a
Mhm.
number. In other words, if you had 4 square, that's right here, Maureen. Suppose I
Uh-huh.
had, let me just put this here. Okay. Now let me just put, okay. Suppose I had 4 and I want to raise this to the second power, right? And want to take the square root of this. So let me just put a square root in front of square root symbol in front of this. So my square root symbol is hidden. Take that out. Okay. My square root. Okay, I'll just write in front of it. Okay, square root of, okay. So Maureen, if I take the square root of 4 square, what do I get?
There were 4 squares and
Mm-hmm. What would that be
4.
equal to?
4.
No, the square root. What would be the square root? When the square root is really raising something to the 1/2 power. So
Mhm.
4 to the second raised to the 1/2 power would just be 4 to the 1,
Um,
right? Which I can write as 4. And I'll put a 1 there. So you see that's to the 1 power. Okay.
uh,
So square root is raising to the 1/2 power. So 1/2 times 2 is 1. So that's 4 to the 1 power that we can just really write as just 4, right?
uh,
So normally we don't put the 1 power. We just leave it out. And if you don't see a power, that means it's raised to the 1 power.
uh,
Got it?
yeah.
So over here, if I take the square root of 36 and the square root of L square, what's the square root of 36?
Um,
What number times itself gives 36?
5.
What? What number multiplied by itself,
Oh,
Maureen, gives
oh,
36?
uh,
What is it? A number multiplied by itself to give 36. It's 6,
6.
because 36 is its perfect square root, right?
Yeah,
Square root of 36 is 6.
it's 6.
The square root of L squared is just L.
Yeah.
So if L is the length, and that's equal to 6, and the area is 72, the number that multiplies by 6 is my width. And that can only be 12 because 6 times 12
It's
gives
72.
72, right?
Uh,
So that means the length is 6 and the width is 12. Okay. So we will be doing more algebra. That's just an introduction to the algebra. That's what we'll be starting on next time. You'll send me the answers to that practice probability and statistics sheet.
Okay.
Okay. I'll send you what we went over today. I'll also send you 20, what was it, 21, 22, 23. I'll send, let me make a note of that. I'll
They're gonna
send
say
you,
21 and 22 only.
yeah, 20, 21. Well, I send them all because 20, because I got to send those to everybody. 21, 22, 23 answers I'll send to you. So that's what I owe you. We will do algebra. I'll probably not send you any algebra. We'll do it all in class. I'll just put the worksheets on the screen and we'll go through them in class. All right,
Okay.
Maureen?
So you can just send the practice test.
Yes, I'll just send that the practice probability
Okay.
one we went over, and you can just email me or you can text me the answers, the 10
Yeah.
answers. All right.
Yeah.
Any questions on anything we went over?
No.
So our next topic after probability and statistics is algebra. So we'll be spending a good time on
Could you send me 2 algebras just to see if I could figure them out myself?
oh
Not
yes. Oh
not the ones
sure.
that we do just now. Yeah.
No, you want some new
Yeah.
algebra.
Yeah. Yeah.
Okay.
Just 2. Just 2
Okay.
with the quiz.
I'll just send you 2. And then if you
Yeah.
want to text me the answers, I'll text you back and we'll see
Okay.
if you have them. That's very good,
Yeah. I can
Maureen.
test them back in with the quiz.
Very good. Maureen, you like doing extra work. I like that about you. You like to keep
But
alert and practice. Huh?
I got none. I have nothing else to do but sit down in the house all day long because I can't walk up like you want time.
You're right. Absolutely. Absolutely. How's Maxine doing?
But she's still in hospital.
I know.
Yeah, she got a lot of pain because the pain she got is nerve pain.
Oh boy.
And the
Yeah.
only time she sleep is sit comfortable when I give she the medication.
Oh boy. Yeah, I know. I don't think she found that those scores. I told her I would try to get the lady.
She had them home and she was gonna fast. She was the same time she was looking for them. She takes it, so they had to call the ambulance and send she back to the hospital so that she could get to look for them.
Oh yeah, yeah. Well,
And she's still in hospital on it now, yeah.
yeah, I sent a notice to the lady at 1199 who's coordinating all of this to let her know that Maxine was in the hospital. And hopefully because they have a record, the state has a record of that. So
Yeah.
I let her know that
Yeah, because
Maxine was in the hospital.
she had only failed the mask by taking
That's
7
it.
points.
Yeah,
Yeah.
I know she took it one time and passed 4 out of 5, which was excellent. And
Yeah.
I would love to see her get her diploma. And I sent last week after I talked with Maxine, because she called me, I called her back. And she said she was still in the hospital. She sounded really weak. And
Yeah.
she's been in the hospital for such a long time. And I sent a message to the person in charge of getting all of this information to the state to let her know I had 3 out of my 7 students who hadn't received their diploma yet. And I said, let her know that Maxine had been in the hospital. So hopefully they can pull her results out and get her diploma to at least I tried, yeah, because she deserves it. She really does. To go in there, without doing anything and passing 5 out of 6 is excellent.
I know.
Yeah. So, and hopefully she'll feel better. That's a
But the other
long
little,
time.
but the other little bad behavior, Cassian.
Yes. What about Kathy Ann? How's she doing?
But when I went to Barbados in 2019, I had like I had like 2 double funerals. Then I went to England.
Right.
And the mother was to send she back to me. So the mother decided to keep her and to split her between she and the father that never give she nothing. Even when she did up to seventh grade, nothing. So now she at the father and she's not doing nothing. They said
She not going to school, doing the Zoom classes or?
she got the Zoom, but she doesn't do the work. Last time she get all X's, and now they said and tell the father that she gotta repeat eighth grade because she ain't doing the work.
Oh no.
You see,
Why didn't she send her back to you? Because
so
you,
he going to work and she by herself.
but
So
that's
she
why she should be with you, because at least you got your grandchildren there and
yeah.
they could help her because they are all advanced, right?
But then go to school today and tomorrow. There's go school like 2 days, Mondays and Tuesdays.
Yeah.
And then they just do it. Like, but then last reports they get 90s and 98s and 97s and things. And Mikey done got his high school pick. G done got Mikey high school pick up and everything.
Yes.
Yeah, but Patricia gonna be still there because Patricia is now in seventh grade or something like that. Or sixth
Oh
grade, something
boy.
6 or 7. Because she's 12. Yeah.